Hello everyone, let's learn about discrete time, convolution sum, and also look at a numerical example. Discrete time convolution applies to LTI system. Let's explore this system with more details. I have a system with the input sequence x of n that produce output sequence y of n. The system has impulse response n of h. Let's consider what is impulse response means. If I were to apply delta function delta n on the input, it is a single sample with value 1 a time and equal to 0. That produce the sequence h of n. If I delay this impulse by one place, delta n minus 1, because the system is time invert, we got the same impulse response which delayed the same mole. Now we enter sequence x of n has the value I will pick up specially, such as x of 0 and n equal 5. We have x of 5 and back here minus 4, n equal minus 4, and we have the value x of minus 4. I can take each of these value in the input sequence and multiply it by delta, that is delta function shifted to the same place as symbol value. This way that I can view x of n as being composed a large sum of the scaled and shifted impulse. For example, delta n plus 4 is scaled by x of minus 4. Here at n equal 0, we have x of 0 times delta of n. Here another example, x of 5 times the delta located and equal 5. Now y of n is likewise a large sum of values. The scaling factor remains the same, but we just replace or change delta with h. We then see that we have some shifted and scaled impulse response. Now let me generalize that as a following. This is out of the sum running from I equal negative infinity to positive infinity. I have picked out three special value here: x of I multiplied by h of I and shifted amount with minus I. We call this convolution of sum. Let's take a look at a numerical example. Here I have sequence x of n composed of 4 values. These values with underline notes that location of n equals 0 in the sequence. The impulse response for the system looks like this. And I have also indicated the point at which n equal 0. We want to find convolution x and h. The asterisk is the convolution operator. We have here my impulse response in the top, and underneath out we have my input sequence, and I am taking care about vertical. The n equal here 0. The n equal 0. Now I'm going to multiply these together. 4 times 1 equal to 4, and 4 times 2 equal to 8. 4 times negative 4 equal negative 4. Now what we see here are amount to the value x of 0, which is 4 times impulse response h of n, and I equal to 0. We do the same thing here. 1 times 1 equal to 1, 1 times 2 equal to 2, 1 times negative 1 equal to 1. The cross response to the cos x of 1 times the shifted version of the impulse response. That's why we have the toggle going here. We need to have the shifted impulse response, and now we do the same thing with the rest. According to the convolution sum, we need to add all these together, and after we add these together we have 4 and 9, 0, 8, 8 minus 4. This sequence is my result for y and of h, y of n. We also need to make note of n equal to 0, and that located right here, and that's the convolution sum.